Hello everyone, I'm Bürgen Aysu. To introduce myself, I have my architectural bachelor's degree at Yıldız Technical University. Also, I have two master's degree, all based on high-rise buildings. First one about high-rise structural systems and the structural concepts in Yıldız Technical University, and the other one is on planning multi-use high-rise building in Chicago, Illinois, United States, Illinois Institute of Technology. Here we will discuss with examples about multi-use eco-tall structures in context of vertical eco-cities as a part of the PhD program Ecological Design Principles of Housing Settlements by Professor Dr. Semih Eryıldız at Okan University. By the end of 19th century and with Industrial Revolution, migration from rural areas to cities vastly increased. Cities started to expand rapidly, and new urban and regional planning needs arose. New building typologies developed to house and service this growth in dense cities, so-called high-rise buildings, tall structures. During this period from 1850s up to 1980s, loss of balance of ecological system was observed due to uncontrolled expansion and development of cities laterally, or we can call horizontally, and the needs of a city and its inhabitants to function properly and buildings to house and service inhabitants. In 1980s, early 1990s, sustainability and sustainable design approach culminated a new phenomenon called eco-cities. Mid-2000s up to today, architectural design, all of engineering, regional and urban planning concentrates on sustainability, thus this phenomenon. A phenomenon, vertical eco-cities, might be a solution in collaboration with multi-use eco-tall structures for replanning, overgrowing, and expanding cities. From 1800s up to today, cities have overgrown, expanded, and overcrowded with formation of new districts. As an example, residential, financial, and industrial districts. But unstoppable horizontal expansion of cities created lots of problems, like more land use, thus destroying the agricultural areas, more need for vehicular transportation, both private and public, need for a net of complicated infrastructure developments like sewer, electrical, communications, usable water systems. All those needs and developments and uncontrolled waste management and excessive consumption of habitants, rising carbon emission due to transportation, industry and heating systems, and consumption of excessive natural resources, materials, started destroying the natural environment and thus the ecosystem. As cities grow dense, with the advancing construction technologies, structural systems and materials, need for new building typology was a must. The Great Chicago Fire in Chicago in the United States in 1871 and the new city plan created from scratch was pioneer for a new idea for a new building typology, functional tall structures or high-rise buildings. Chicago School is well known and was established by most successful architects with their different approach in design of high-rise buildings at that era and expanded all over the world. At the beginning, high-rise buildings only were designed as single-function buildings, office, hotel, or dwelling, and core solutions were effective enough to service all floors with less loss of rental areas. But as we approached 1960s, a new definition was introduced, multi-use high-rise buildings, that was designed as 2 or 3 function buildings, all functions stacked on top of each other as building gets higher. This approach demanded more complex core solutions, hence decreasing the efficiently use of functional spaces. As we advanced in technology and the unstoppable race for constructing the tallest structure, nowadays, most of the tall structures must include multi-functions. After 1980s, sustainable and ecological design of such multi-use tall structures also must be achieved, so core solutions and spatial solutions and relations between varying functions of sustainable tall structures became more complex and complex. Sustainable architectural principles are resource management, life cycle design, and design for human. To achieve and complete the design process of sustainable buildings, we must follow some strategies. These are effective use of energy, water, materials, and occupied or unoccupied building spaces, pre-building, building and post-building periods, conservation of natural conditions, urban design, and regional planning and design for human health and comfort with safety. To achieve a sustainable design, social sustainability, economic sustainability, and environmental sustainability must coexist in the design process of multi-use tall structures. If you look at the ecological principles, ecology is the science that studies living things in the environment and their interactions with their living and non-living natural environments. Each part of the ecosystem has a specific function and acts according to a purpose. Although man may not seem to be a part of nature and the ecosystem, his ability to think and change his environment is a feature bestowed by nature. He is a part of nature, like other living things. All the qualities possessed by man belong to his nature. Man should perceive nature not only as means of use, but also as unity in which he can continue to exist together with nature, like other species. The principles developed from this are as follows. Firstly, rehabilitation of the environment by making green belts in rural and urban areas and giving importance to progress in the agricultural field. Second would be adaptation to the biological environment by environmentally compatible development plans and constructions compatible with climatic conditions. The third would be balanced development, buildings with low energy consumption and preservation of existing ecological features. The fourth would be stopping the spread of over large areas by optimum use of urban areas, establishment of effective transportation networks, and limitation of urban sprawl. The fifth would be the energy saving by sun, natural ventilation, and lighting or insulation, and reducing energy consumption with a design suitable for climatic conditions. The sixth would be obviously affordability. The seventh would be healthy conditions by reducing pollution and improving the environment and recycling of waste, recycling and reusing. The eighth would be the society, participation of the community in management and development. The ninth would be ensuring social equality, equal rights for all, equal living conditions. The 10th principle should be respect for history by restoration of existing historical buildings and landmarks and recognizing cultural diversity. The 11th would be enrichment of the cultural space. The 12th would be improvement of the biosphere. When we look at vertical eco-cities and eco-toll structures, the idea behind designing ideal cities goes back to the end of 19th and the beginning of 20th century by the adverse effects of industrialization and industrial revolution, and also increasing population and pollution. Two main studies come forward based on these idealization approach of these cities, Howard's and Corbusier's. However, their approach mostly contradicts with each other, although they have some common ground at some points. Garden city phenomenon of Howard that we can see in figure 1 and 2 was to spread the population to clusters of smaller cities of not more than 30,000 population and agricultural and forest areas around the city-centered model in a circular orientation from center to outward. The city center would include green space belts, cultural and social and governmental functions. The forest and agricultural areas would be the most outer cluster. Then inward, smaller cluster of cities with residential and industrial areas, and then the main city center. This model of ideal city planning was also based on the term of zoning of modern urban and city planning approach. Garden city model of Howard was an expansionist approach, with smaller population of clusters of small cities around the city center, thus more land use and infrastructure and transportation. If we look at some examples of garden cities, Lichworth Garden City in London and Welwyn Garden City in London that were in order 55 and 33 kilometers away from central London area. And there were some design plans in Italy also based on Garden City model of Howard's between 1950s and 1960s. On the other hand, Corbusier defined his ideal contemporary city approach by less expansionist cities with more concentrated population of 3 million divided into three groups, which we can define as urbanities, suburban, and mixed. Urbanities was described as habitants that both live and work in the city center. Suburban was described as habitants living and working in garden cities, and mixed as living in garden cities but working in the city center. Corbusier's approach of contemporary city was the starting point of vertical cities, still using Howard's ideal city model of garden cities, but increasing the population of city centers by adding also residential and commercial functions to decrease the land use by concentrating both residential and commercial population in tall geometrical, glass and steel, or concrete or composite structures, and decreasing pollution and transportation with straight, grid, linear, well-planned city planning and access in urban areas. The idea of those structures to be created would also create more functional and spacious areas at city centers. Garden cities would still exist as called as the suburban areas that house mixed users and who live and work at the suburbs. Those structures would have the common amenities at the ground and some on roof of the structures to increase sunlight access. Some examples of amenities could be kindergartens, social areas, and pools, etc. Between the blocks, more common green space and park usage would be available for all habitats. With Radius that we see in figure 3, which also we can call as Shining City, proposing a functional transportation network, large green spaces and living spaces with lots of sunlight, the project proposes both a new standard of living and a new, better society. In addition, with Reduce emerged out of nothing, Justin John Locke's proposition about tabula rasa, which means also a blank plate. In the area designated for the construction of the project, there is nothing but the remains of destroyed vernacular European cities. Tabula rasa, blank state, is the theory that individuals are born without built-in mental content, and therefore all knowledge comes from experience or perception. Epistemological proponents of tabula rasa disagree with the doctrine of innatism, which holds that the mind is born already in possession of certain knowledge. Proponents of tabula rasa theory also favor the nurture side of nature versus nurture debate when it comes to aspects of one's personality, social and emotional behavior, knowledge, and sapience. John Locke, a British fatalistic philosopher, argues if everything is innate based on his tabula rasa view. According to Locke, there is no innate knowledge, and human acquire all this knowledge throughout its lifespan from its feelings and experience. Utopian architecture and utopian cities are highly debated even today. But once considered as utopian approach, it is turning to be a fact today through every level of design. Facts such as the existing and subjectivity of utopias make it impossible to build a utopia cities, but adopt idea to turn it close to a reality. With Reduce is also a project that has been heavily criticized for utopia cities. Although Corbusier had thought about every important points and subjects such as healthy living, traffic, sound, public space, and transportation, because there were many points that Corbusier skipped that this approach was named as a failure. Many proposals such as exemplary houses and standardization of life were harshly criticized for not being compatible with human life and scale and nature. Corbusier used this idea he created in Radius in his proposals for European cities such as Paris, Antwerp, Moscow, and North African countries such as Morocco and Algeria. In 1949, he had the opportunity to apply the solid zoning system and geometric plan layout he had developed in Punjab, India. The strict order established by Corbusier will reduce has inspired many cities built in the future. Although Will Reduce was an unexecuted project, Corbusier applied the ideas that sprouted from the city he created in other projects. Unit de Habitation, a mass housing project in Marseille, is one of the most important examples of these. In figure 4 and 5, we can see the numerous Algeria 1933 proposal of a new residential quarter of unit de habitation, and also Corbusier's sketch at that point for his proposal for the design of unit de habitation in Algiers. In figure 6, we can see the unit de habitation Marseille, France, 1945. The unit de habitation de Marseille, the founding work of architectural brutalism, is the major test of new mode of housing based on the balance between the individual and the collective. Unit de Habitat Marseille, France, takes the form of a housing bar 135 meters long, 24 meters wide, 56 meters high, and mounted on stilts. 330 apartments divided into 23 different types can accommodate a population of between 1,500 and 1,700 occupants. Having at their disposal on the 7th and 8th floors a shopping street and a hotel restaurant, together with a kindergarten and sports facilities on the roof terrace. The constructive principle adopted, the so-called bottle rack, consists in building apartments inside an independent frame of posts and reinforced concrete beams. The apartments are made up of standard elements assembled on the site. All the apartments are dual aspect except those on the south side. A sunbreak loggia provides an open air facility at the same time as limiting exposure to sunlight. Protected by double glazing, the apartment interiors are subject to the two basic rules of naval and monastic architecture: rationalism and simplicity. The living room, open on two levels, is the nucleus of the family, which we can call home. Upstairs, the parents' room occupies the mezzanine. Also in figure 8, we can see the blackboard sketch of Corbusier looking at the geological approaches, the sunlight and the sound, and the connection at the street level. And in these figures, we can see the floor plans, typical partial sections, and typical plans, which were created in a modular design that was created by Corbusier. All these plans were based on a 3.6 meters modular system elongated through the building and double stories with a mezzanine. The kitchen is equipped like a laboratory. Electrical cooker, refrigerator, rubbish chute, and storage racks. The entire apartment is fitted with racks replacing traditional storage. The ventilation of the kitchen, bedroom, and toilets is mechanically operated, while the entire apartment is supplied with clean air by an air conditioning system. These facilities were not found in low-cost collective housing units at that time, and the standard surface areas of unit de habitation are greater than these by between 40% and 50%. The 17 stories below the terrace are connected by 8 interior streets which, given the overlap of two-story apartments, each serve 3 floors. Each street is accessed by a battery of 4 elevators, complemented by a service elevator, and 3 emergency stairs, which we can call fire stairs. The entire building and its equipment are designed in terms of modular, the universal measuring unit conceived by Corbusier. By 1980s, a new approach, ecological design, emerged. First was an idea, but as seen, it's a must today. So urban and regional planning also must be done ecologically. Eco-cities emerged with this idea, hence to design and build sustainable structures. But as cities grow, the need for tall structures is also inevitable, hence eco-toll structures must be built, and cities with these toll structures creates this vertical eco-city phenomenon. When examining the vertical eco-city phenomenon, another approach would be to layer the city, meaning besides zoning the city horizontally, also zoning the different vertical layers of the city. Just like in music, building the background and supporting the rhythm and development of the song with different dynamics. For example, basses, drums defines the rhythm and the infrastructure of the song. On the other hand, hierarchically, the other partitions from the lowest infrastructure to the main performer level feeds the needs, ends with emotions and the enjoyment of the audience. The city could be layered in different levels and further into the building to create a web of communicating, participating functions based on needs, a reoccurring symphony. Seen in figure 10 and 11, the city could be condensed to singular blocks to accumulate the same needs with less land usage, with less transportation and infrastructure connections needs, creating fewer shadow areas if the toll structures positioned based on sustainable design rules based on geographical data. Different layers could be formed vertically, starting with infrastructure tunnels, services, and vehicular layers, pedestrian, green space needs, and further connections between toll eco-structures. Further research could be conducted on vertical eco-cities to integrate the toll eco-structures as not just standing still with only housing its own functions, but also with including the amenities and linking them as a whole city and building integration. In figure 10, we can see in 2A the condensation of units in a single modular blocks. So if we were to compare eco-cities still to a vertical eco-city, we could easily take 15 units and condense them in a one toll structure. The next one would be the 2.B, which would be our shadow simulation. When the city spreads wide and the buildings come from 2, 3, 4 floors, you will have more shadow levels at the ground. But if we can condense all these functions and amenities in a single building, and if we can use the right sun direction, we can really control the shadowed areas in the site. And also in 2C, the layering of the city can be achieved by using all this infrastructure at the lower levels, and then a service access, the vehicular access, and the pedestrian access. And when the buildings arise, we can interconnect them with social areas. And also in figure 11, we can see in a larger scope, that if we condense all these units into singular buildings, we would end up with more green space. Hence, with the use of layering in the city, under this green space, we would have all our infrastructure and the vehicular access. Also, besides that, we can also include some other amenities like more common use areas like health, education, and cultural services in buildings or in different layers. If we talk about multi-use eco-toll structures, first mostly built as theological non-functional structures like pyramids, etc., and then with the industrialization used as condensed functional buildings and prestige buildings, toll structures always coexisted with the history of humankind. There are various definitions for toll structures, but the most common one is the structure that house different functions and large user numbers. Habitants require also intense and special professional architectural, structural, mechanical, and electrical engineering solutions, and taller than other buildings in the city in its surrounding and the environment where they are built. After 1980s, to design such structures also must be done using ecological design principles, hence sustainability. Sustainable architectural principles are resource management, life cycle design, and design for humans, as we have mentioned before. The further question is that could the eco-toll structures forming the vertical eco-city be sustainably designed, not just being single buildings in its own housing multiple functions like residential, commercial, etc., but with interactions on different levels that houses the ecological needs of the city, forming different layers not just at ground level, also at lower layer of the vertical eco-city, but also at layers above ground level and its own design. If we look at some case studies, architects Norman Foster, Ken Young, and Moshe Safdie's, this idea seems plausible. But if we go back to figure 10.2.c, we can see what we are talking about, just layering the city. We were going to look at some case studies from Norman Foster, Ken Young, and Moshe Safdie. First, if we start with Norman Foster. Norman Foster, Baron Foster of Thames, is a British architect and a designer, closely associated with the development of high-tech architecture. Foster is recognized as a key figure in British modernist architecture. His architectural practice, Foster and Partners, first founded in 1967 as Foster Associates, is the largest in the United Kingdom and maintains offices internationally. He is the president of the Norman Foster Foundation, created to promote interdisciplinary thinking and research to help new generations of architects, designers, and urbanists to anticipate the future. At the 83rd UNECE conference, Norman Foster, founder and CEO of Foster and Partners and president of Norman Foster Foundation, launched the San Marino Declaration. It's an UN-approved declaration that includes principles for sustainable and inclusive urban planning and architecture to promote the broader vision of sustainable development. It obliges every city to plan urban infrastructure and buildings in accordance with the integrated principles of ecological design and sustainability. The first goal would be inclusion, diversity, and respect. A clear goal of declaration is to prioritize the residents. Every household, including special needs, is considered to promote diversity and equality. This project is to be guaranteed, among the other things, by making access to living spaces open and affordable. At the same time, the principles aim to establish respect between different cultures. Discrimination and corruption should no longer have a place in urban areas. Ultimately, a sense of social responsibility should be established. Proximity to the people is the motto. The second goal would be resource and climate protection. Another focus of the principles declared by Norman Foster is respect for nature. So they force the efficient use of resources to protect them, and environmentally friendly use of energy is also on the agenda. Among the other things, recycling should be part of the status quo. These commitments, in combination with low-emission energy generation and transport systems, should lead to climate naturally in the long term. And goal 3 would be the security. In addition, the residents of the urban spaces should also feel safe. To this end, the principles of declaration define internationally recognized quality standards for architectural planning. They also include standards for adaptable spaces that can respond to potential crises such as natural disasters. Security is therefore guaranteed in various dimensions. One of the Foster projects that we can mention is the Euro-American Innovation City, as seen in figure 12. It's still under development. This city is a vibrant, mixed-use development located at the heart of Central Business District in Hangzhou, China. The site is part of the city's wider master plan, increasing the number of cultural, commercial, and residential buildings along a cultural landscaped axis. The 346,450 square meter development comprises of two office towers, four residential towers, a public plaza, and an IT incubator with a retail mall on the lower levels. A uniform podium connects the buildings with a ribbon of retail and public amenities. The slender towers are softened by 45-degree chamfer corners, creating view corridors into the development for the surrounding streets. The scheme is unified by a refined palette of high-quality materials, including stainless steel and GRC paneling. The two 200-meter-high office towers are adjacent to the Queentank River and form a striking gateway to the complex. The development is permeable with multiple layers of access across four layers, which we mentioned before layering the city. Ground-level canopies extend outwards from the podium, indicating the various entry points to the scheme. Sheltered drop-off zones blur the lines between inside and outside, while providing direct and convenient access to the lobbies within. The office towers attract international technology companies and deliver high-quality, flexible workspaces for government departments. A single lobby connects the bases of the towers, encouraging impromptu social interactions between workers. Within the towers, generous sky gardens and double-height green amenities areas also provide a variety of pleasant breakout spaces. Along Lear Road, the south-facing residential towers have stepped messing to allow more light into the development and create a dynamic skyline. The tower's slender volumes allow for cross-ventilation and increase natural light levels. Their distinctive rounded edges set them apart from the office towers on the other side of the site. Triple-height lobbies visually connect tenants with roof gardens on the upper floors. A collection of connected amenities, including a club, spa, nursery, and pool, redefine the residents' living experience. A landscaped central public plaza is the focal point of the scheme. Joining the development's office and residential areas, the plaza provides a place for workers, residents, and the public to gather. It offers a natural backdrop for social gatherings and community events. Breathable green spaces are an important element for the scheme, improving physical and mental well-being in the aftermath of the COVID-19 pandemic. The IT incubator is located on the north side of the plaza at the top of the podium. It has been designed to attract emerging technology startups with unique landscaped terraces that can be viewed from the surrounding towers. Horizontally stacked planters evoke the dynamic from the other region's tea plantations. Euro-American Innovation City's sixth tower offers spectacular views of the development and the city beyond. In figure 13, we can see all this public space and interconnecting levels at different levels of the city. Although this is layered above the ground level, this also could incorporate below-level interconnecting spaces. And an overall look at the Euro-America Innovation City in Hangzhou, China. One other project that we can mention from Foster and Partners is the Forestias. It is still under development design scheme. It started at 2016, still is expected to end at 2025. Is designed at Bangkok, Thailand. The Forestias is a residential-led master plan with a large forest at its heart, situated on the outskirts of Bangkok. It provides a template for future urban living in Thailand. The pioneering development focuses on three primary themes of serving the community, promoting intergenerational co-living, and connecting with nature. The idea of re-establishing a positive relationship with the natural world has been brought into sharp focus by the COVID-19 pandemic, as we all have lived through. The site is divided into two zones, with the northern areas containing more city-level public functions, while the larger southern portion is primarily residential. At the heart of the site, the forest defines the essence of the development, showcasing the relationship between the built and natural environments. Lush greenery surrounds the development, with planted areas that offer a variety of experiences and functions within the forest. As residents and visitors travel through the site, they are surrounded by denser green spaces, offering a sense of escape into an urban oasis. The southern portion of the site contains a number of different housing types, from high-rise to villas, catering to a varied market. It includes three Wisdom high-rise condominium buildings that are designed to perfectly suit smaller family units. There are also Mulberry Grove, as we can call, low-rise condominiums that bring residents close to nature, as well as Mulberry Grove Villas, cluster home residences for extended, multi-generational families who wish to live close together in multiple homes that are easily connected. Another residential offering is the Aspen Tree Residence, as we can call them. These are designed to suit the special needs of older residents with lifetime care services. Capping it all are super luxury villas called the Six Senses Residences. The blurring of boundaries at neighborhood level is achieved by visually reducing boundary walls and hedges to create shared facilities that encourage people to come together as a community, taking its cues from the lively streets found in the traditional neighborhoods. The fundamental idea is to create a fractal diagram of buildings and social spaces that can be replicated infinitely. Here we can see the main common entrance level as figure 16 at the Forestiers Bangkok Thailand project. Another architect that we shall mention is Ken Yeung for his known popularity in sustainable and ecological design. Ken Yeung, born on 6th of October in 1948, is an architect, ecologist, planner, and author from Malaysia, best known for his ecological architecture and eco-master plans that have a distinctive green architecture. He also pioneered an ecologically based architecture since 1971, working on the theory and practice of sustainable design. Yeung's headquarters is in Kuala Lumpur, Malaysia as Hamza and Yeung, but also with offices in the United Kingdom as Llewellyn Davis Ken Yeung, and also in Beijing as North Hamza Yeung Architectural Engineering Company. Rising over global cities, the modern skyscraper has long been a symbol of economic growth and environmental decline. For years, they have been revealed by environmentalists for being uncontrolled energy consumers. Malaysian architect Kenneth Yeung acknowledged the skyscraper as a necessity in modern cities and adopted a pragmatic approach to greening the otherwise unsustainable building typology. Yeung's bioclimatic skyscrapers blends the economic of space and sustainability and improve the living standards. A champion of sustainable architecture in Southeast Asia, Kenneth Yeung's works is driven by an ecology-based approach. He was a student of the Scottish landscape architect Ian McHardt, who encouraged Yeung to design according to a regional microclimate. Best known for his green architecture and master plans, Yeung's designs displays a distinctive green aesthetic that performs beyond conventional rating systems. With many successful projects in his portfolio, Yeung became well known for reimagining skyscraper design in fast-growing South Asia. Kenneth Young situated his practice at the intersection of theory and practice, having authored a few books on skyscraper design. In his book The Skyscraper Bioclimatically Considered, Young describes bioclimatic architecture as the use of passive, low-energy techniques such as building configuration, shading, component placement, material selection, solar and wind-related orientation, natural ventilation, and skycords and vertical landscaping. In the book "The Green Skyscraper: The Basis for Designing Sustainable Intensive Buildings" elaborates on Young's justification for the focus on skyscrapers as a means of ecological improvement in growing cities. According to Ken Young, there are three ways to make an ecological design: nature-centered, techno-centered, and anthropo-centered. Beginning of the design process, Young mentions that the first approach of these three shall be nature-centered. In addition to those, also a building must be functional within the cost and budget range of the customer, constructed on time, be of high quality, beautiful, which in terms of what kind of understanding of beautiful or beauty that makes users happy. One of the design competition projects from Hamza and Ken Young that we are going to look into is the Longkou City project. The City in the Sky project transforms conventional concepts of urban design into high-rise building form as vertical urban design, which we also call as vertical eco-cities. In concept, also we are talking about multi-use eco-toll structures. From this, an understanded urban typology is infused into the traditional planning of Chinese cities, catalyzing the emergence of an ambitious and innovative city. The architectural significance of the City in the Sky is its future to effectively reduce the density of buildings and population on ground level, which is now able to be conserved for greening purposes. The master plan layout is primarily developed based on principles that prioritizes ecological connectivity and super green development in order to maximize the ratio of natural ecology to the overall landmass of the Longkou Financial Center. A series of ecological corridors is proposed as interlinked channels, establishing a green network, thereby bringing a comfortable and pleasurable space for the public. It will likewise serve as a vast wetland park with various bird species that will visit and improve the locality ecological diversity. Further to that, depending on the local four-season climate in Zhenghu, a series of vegetation has been carefully selected and assimilated into the design of the super high-rise twin towers. The two super high rises stand out on the northern end of the Longkou Island, as if resembling a living urban tree, one of which will hold an essential role of purifying the air. In order to greatly enhance the locality ecological diversity, the existing lakes will be transformed into a huge wetland park to attract birds that visit Longkou Island in order to achieve a city where architecture and ecological habitats coexist. In addition to meeting the design requirements of the building, the scheme fulfills and exceeds the benchmark for green landscape planning. Moreover, the greenscape of Longkou Financial Center is not limited to the ground level. The design of the twin towers is integrated with the vertical vegetation corridor, of which vegetation connects upwards from the ground plane to the buildings, creating a sense of three-dimensional depth and a hyper-green spatial design. This fully embodies the hyper-green urbanism that is desirable for the region. As a continuation of Kurokawa's conceptual proposal of an eco-city vision, while keeping a strong Chinese cultural influence as a reference for the design of the CBD master plan. The scheme draws on the long-standing history of Ruinat to develop the master plan and design of the three sets of buildings. In terms of the form, the building facade of the super high-rise implements the Ruinat's patterns, with its facade composing of interweaving form that highlights the charm of the local traditional art and culture. This is interpreted in a contemporary manner. Architecturally speaking, the harmony between architecture, ecology, and humanity requires rethinking to create a group of active buildings. Demonstrated within the proposal, these active buildings are breathing buildings that form the City in the Sky project. Through the use of sky bridges, escalators, and connecting bridges between the twin towers, a multi-layered connectivity is realized, and the journeys within the buildings are further introduced with meaningful paths between the destinations. Championing the principle of ecological and green development, the super high-rises incorporate elements and green features to create sky in this project. A series of sky gardens are created at intersection points between the towers. Other green infrastructures and features include ecological bridges and vertical vegetation corridors, connecting green spaces from the ground plane to the sky and hence organizing them in a Sky City Garden, which names the project. This concept allows for the plants to penetrate the building unhindered to enhance biodiversity and to promote indoor ambience and natural ventilation. These sky gardens and sky courts generate shared open spaces for users to gather and socialize. The thriving vertical community is not only beneficial in terms of promoting and cultivating community awareness, but also in catering for communal activities. The residents may enjoy the spectacular view of the skyline of Zhengdong New District in this space as they hold activities also. The super high-rises will provide a diversified, complementary, and integrated city in the sky through varied public and private facilities that accommodate for businesses, entertainment, and landscaping. This encourages a wide range of users to enjoy the facilities within the Twin Towers. At the same time, it renders the concept of a vertical city as though it is a community walking on air. The multifunctional Sky City also aids the establishment of harmony and respect between human beings, all which leads to a peaceful and marvelous social and cultural environment. From Kenyang's onwards, the City in the Sky project transforms conventional concepts of urban design into high-rise building form as a vertical urban design, which is in our subject as a vertical eco-city and a multi-use eco-toll structure. The master plan layout is primarily developed based on principles that prioritizes ecological connectivity and super green development in order to maximize the ratio of natural ecology to the overall landmass. A series of ecological corridors is proposed as interlinked channels, establishing a green network, thereby bringing a comfortable and pleasurable space for the public. In here, we can see all these interconnecting levels with social activities between buildings. Greenscape is also active in the building with routes that are created as walkways. And we can see the continuity of landscape at the ground level throughout the building. And with amenities also included in the building at ground level, also in the sky towers. Another architect that we shall mention about sustainability and ecological design and also vertical eco-cities and interconnected in the city is Moshe Safdie. Moshe Safdie, born on July 14, 1938, is an architect, urban planner, educator, theorist, and author with American, Canadian, and Israeli citizenship. He is known for incorporating principles of socially responsible design in his 50-year career. His projects include cultural, educational, and civic institutions, neighborhoods and public parks, housing, mixed-use urban centers, airports, and master plans for existing communities and entirely new cities in North and South America, the Middle East, and Asia. Habitat 67 was the major theme exhibition of the 1967 Montreal World Exposition. As a landmark demonstration project, it pioneered a vision for urban housing using the technology of prefabricated construction, as a breakthrough building type that continues to resonate today. Habitat seeks to create a vital neighborhood with open spaces, garden terraces, and many other amenities typically reserved for the single-family home, now adapted to a high-density city environment. 365 construction modules connected to create 158 residences. These range in size from 600 square foot one-bedroom dwellings to 1,800 square foot four-bedroom dwellings. In all, there are 15 different housing types and typologies. Stepped back in their modular placement, each residence has its own roof garden, play areas for young children, and provided throughout the building. 3 elevator cores direct vertical circulation throughout the complex. Elevators stop at every fourth floor to serve pedestrian streets included in the design. The streets are continuous throughout the project, and access to dwellings is directly from them. The project incorporates both covered parking for all tenants and additional visitor parking area. In Habitat 67, all the parts of the building, including the units, the pedestrian streets, and the elevator cores, participate as load-carrying members structurally. The units are connected to each other by post-tensioning, high-tension rods, cables, and welding, all of which combine to form a continuous suspension system. The interior components were produced, assembled, and installed into each box unit in the factory, with the single-unit bedroom of gel-coated fiberglass kitchens manufactured by Frigidaire and window frames made of Geon plastic. In Habitat 67, we can also track back this design to Corbusier's Unit de Habitat settlement, or the project that he the main idea behind that was the naval and monastic approach. Two basic rules were applied: rationalism and simplicity. In this project also we can see this rationalism and simplicity. Repeating units stacked on top of each other with open corridors, which also is a sustainable and ecological design approach with terraces with green spaces on top. This project could be improved much more further, but the horizontal settlement of the project that we can see in the next figure made it maybe a brutal approach in a city design. But further, this approach might be taken into consideration if instead of horizontal spreading cities, we could create a naval and monastic approach with modular units in multi-use eco-toll structures which are interconnected in different levels, also under ground level as city layers with infrastructures and then service levels and then vehicular levels and then pedestrian levels and then interconnecting multi-use eco-toll structures. Maybe as in Habitat 67 of Moshe Safdie, the stacking layers of prefabricated units as neighborhoods could be repeated in a multi-use eco-toll structure, as seen in these sections. Next project that we are going to talk about is again Moshe Safdie's project that we were talking about before stacking all these units and the Orca mixed-use development and park at Toronto, Canada, and still in design process. The Orca project reclaims a west urban site in downtown Toronto by decking over a major rail corridor. Residential, office, hotel, retail are designed around the new 11-acre park, the heart of the neighborhood. The ambitious integration of private development and a major publicity accessible park creates a vibrant park-oriented community for Toronto. Toronto Orca decks across the 100-meter wide active rail corridor, which previously split the city. By tucking vehicular access and parking within the decking structure, 65% of the site area is left as publicly accessible open space, exclusively for pedestrians and bicyclists. The Diversity Program Park provides a major amenity for surrounding community. The project includes 8 residential towers with approximately 3,000 units of housing, 900,000 square feet commercial office tower, and 450,000 square feet of retail space opening directly onto the park. The interconnected towers are positioned to preserve sunlight on the park and encourage interconnected access to and from the surrounding neighborhoods. The project integrates retail and landscape by tucking shopping under the park. The innovative section turns the traditional shopping mall model inside out by directly connecting shops, restaurants, cafes, and the park's recreational experiences on multiple levels. The Galleria opens up in a good weather to encourage indoor-outdoor use, year-round vibrancy. The slender residential towers are placed to maximize permeably preserve view corridors and encourage connectivity for pedestrians and bicyclists. The towers are articulated with stepping balconies and connected with elevated bridges containing amenities for residents. The bridges between towers form dramatic urban windows which frame city views and maximize visual porosity. The design reinforces pedestrian and bicycle connections throughout the site, allowing people to freely move through and across the site, both indoors and outdoors, connected to the existing network of streets and urban parks. Toronto Orca demonstrates the potential of a vibrant and active-oriented urban community. The private development provides amenities and ensures year-round activity in the park. Private and public cooperation ensures financing, quality, and maintenance of the park into the future. Here in Orca Mixed-Use Development and Park in Toronto, Canada, we can see all this layering, looking at the infrastructure, all these street levels, also the vehicular access and the pedestrian levels. In this view, we can also see the best use of green space left for pedestrians and interconnecting levels between high-rise buildings acting as amenities and also socializing and green spaces. In this master plan, we can all see that all streets are connected to the project site with open space access as shown as green. And then in this whole project, we can see the landscaped walkway and ramps. And also under the buildings, we can see the retail interior connection, which is in summer conditions is going to open up to the green space. Here are some more renderings about the project because it's still in design when we look at it. Although it looks as a brutal approach, city design as the subject of vertical eco-cities and also multi-use eco-toll structures, it might look as a plausible approach for design, which could be further investigated and developed. As we come up with the conclusion and implications for further research, during the design and construction and lifespan of multi-use eco-toll structures, design and regional planning of eco-vertical cities must be taken in consideration, since the multi-use eco-toll structures have to exist in populated cities, and vertical eco-cities could be a solution for less infrastructure, less carbon emission due to less transportation, and less roof effect, more public and green space at street level, etc. But both the positive and negative effects of multi-use toll structures to the environment and social structure. At the beginning of the design process of a multi-use toll structure, the area that the building will be built, the climate, prevailing wind directions, its geological location, its surrounding, the planned height of the building and number of floors, size of the floor areas based on the function of the building or the functions of the building, weight of the building, the required systems of ventilation and lighting, again based on the functions, the structural system materials required to be used during construction, construction systems, and lastly, a claim should be taken into consideration within the scope of sustainable design criteria. Based on research on vertical eco-cities and multi-use eco-toll structure case studies of Norman Foster, Ken Young, and Moshe Safdie, it is possible to design multi-use eco-toll structures in context of vertical eco-cities. What seems to be the important notion for further research and development would be to investigate the optimal layering and order of functions and amenities on different layers of city and the structure or the building itself. Multi-use eco-toll structures not only include amenities in itself, but also can be linked at different levels with connections, including amenities like green space, health, cultural, educational, religious functions, etc. As a result of this research, there seems to be more positives than negatives of properly designed multi-use eco-toll structures with an adequate integration with the vertical eco-city phenomenon, like less infrastructure connections, less vehicular transportation, less vehicular service, and those excess necessities could be layered below ground level to increase green space and pedestrian usage at ground level. Amenities can be located either at ground level or at different levels of toll structures, linking the structures also to increase accessibility and reinforce the social interaction for their inhabitants and users at different levels. Further research also had to be done on various functions-related core solutions for its optimum location and energy-saving vertical circulation solutions, optimal structural solutions with experimenting and using environment-friendly new materials, energy-saving or producing also energy with the cladding systems, mechanical and electrical systems to reuse rainwater and grey water, and maybe also produce energy using wind power or even using the oscillation of the tall building due to its being flexible. Mechanical systems that might produce energy using return air and maximizing the usable green space also in different levels of the structure. Thank you all for listening to my presentation about multi-use eco-toll structures in context of vertical eco-cities. You can contact me by my Gmail account that was in the first page of this presentation, or by contacting Professor Dr. Semih Yıldız. Thank you very much.